questions 11 through 20 on the 2019 Grade 11 Fermat Math Contest. Line L is perpendicular to the line with the equation y is equal to x minus 3. Line L has the same x-intercept as the line with equation y is equal to x minus 3. The y-intercept of the line L is... Let's draw a quick diagram here to illustrate this. And I think we can plot that pretty quickly. This equation right here. When x is 0, y is minus 3. When x is 3, y is 0. So that is the line right there. So something like that. The line L is perpendicular and has the same x-intercept. So it's obviously going to be something like this. Something like that. Where this is sort of the right angle because it's perpendicular. Okay. And they want the y-intercept. All right. Shouldn't be that hard to figure this out. The equation of L is going to have the form y is equal to mx plus b. Now, since it's perpendicular to that, its slope is the negative reciprocal. This slope of x minus 3 is just 1. So if m for this is 1, the m here will be the negative reciprocal, which is negative 1. So this is negative x plus b. Now, to figure out what is b, we can plug in that point, which is 3, 0. So 0 and 3 for x, that means b is equal to 3. So the full equation is y is equal to minus x plus 3. They want the y-intercept, so set x equal to 0, and when you do, you get 3. So number 11, the answer is C. The first part of the Genius quiz has 30 questions, and the second part has 50 questions. Alberto answered exactly 70% of the 30 questions in the first part correctly. He answered exactly 40% of the 50 questions in the second part correctly. The percentage of all questions on the quiz that Alberto answered correctly is closest to. So 70% of the 30 questions and 40% of the 50 questions. This is what he answered correctly. This is 21. This is 20. So that's 41. And then they want the percentage in terms of all the questions. So that would be 41 over the total. And 30 plus 50 is 80. And that is 51%. So Alberto is not a genius. And number 12, the answer is D. Tanis looked at her watch and noticed that at that moment it was 8x minutes after 7 a.m. and 7x minutes before 8 a.m. for some value of x. What time was it at that moment? Well, 7x after and 8x before, so 7x plus 8x must cover the full hour, which is 60 minutes. So that means 15x is equal to 60. X is equal to 4. It was 8x minutes after 7 a.m. So 8x is 8 times 4, which is 32. So it's 8x minutes after 7 a.m. So 7 a.m. plus 32 is 7:32. And therefore, number 13, the answer is C. The letters A, B, C, D, E are to be placed in the grid so that each of these letters appears exactly once in each row and exactly once in each column. What letter will go in the square marked with an asterisk? Well, let's concentrate on this column first. It has A, E, B. It doesn't have a B or it has A, E, B, doesn't have C or D. Well, C can't go here because C is already here and it can only appear once in each row. So C obviously has to go here and therefore D will go there. That takes care of that. Now let's see, where can we go? A lot of ways, different approaches to this. I'll just go here in that row. That has A, D, and C. It doesn't have B or E. E can't go here because E is already there. E can only appear once in each column. So that means E must go here. And therefore the only letter that's missing is B, so B goes there. All right, where do we go next here? I guess we can look at this column. It has A, C, D. It doesn't have B or E. E obviously cannot go there since it's already in that row, so E must go here, and therefore B goes here. And then I guess keep going with that same strategy. In that row, we have A, B, E. We do not have C or D. C cannot go here because it's already there, so C must go here, D must go here. And I think, where do we go next? I might as well try this one. That is missing an A and an E. E cannot go here, obviously, since E is already there, so E must go here, and therefore A goes here. I think finally we're ready to tackle that row. It's missing a B and a D. It's missing a B, or B cannot go here because there's a B up there, so that must mean that B is here, and therefore D is there. So finally, the asterisk is B, and therefore that means 14 is B. There are 6 identical red balls and 3 identical green balls in a pail. 4 of these balls are selected at random, and then these 4 balls are arranged in a line in some order. How many different looking arrangements are possible? So we have 6 red, and we have 3 green. So we have to select 4. The only ways are 4 red, 3 red, 1 green, 2 red, 2 green, 1 red, 3 green. They can't be 4 green because there's only 3 green to choose from. Okay, so now let's figure out what are the ways. If there's 4 red, there's only one way to arrange them, just the R, like that. If there's 1 green, we can arrange them in the following ways, R, G, and then we just keep changing the location of the G, like this. And that would give me 4 different ways like that. Let's just do the last one because that's going to be very similar. Same sort of story. We have 3 greens and 1 R, so we just keep changing the location of the R. And that would give me basically another 4. Okay, so now we got to tackle this one. That one, I'm confident there's 6 ways since I've done this so many times, but I'll just write them out. R, G, G, RG, RG, G, R, G, and then G, R, G, R, G, G, R, and then the only one left is 2 G's in the middle. If you don't want to write them all out, you can just use choose notation. So from 4, choose 4, and this is just 1. From 4, choose one of those spots to put the 1 G, and that's 4. From 4, choose 2 spots for the 2 G's, and that is 4 choose 2 is 6. And then finally, from the 4 slots, choose 1 to put that 1 red, and that's 4. And as you can see, you get the same results. Whichever way you like better, add them all up, and you will get 15. So number 15, the answer is 15, and that would be choice A. In the diagram, each line segment has length x or y. Also, each pair of adjacent sides is perpendicular. If the area of the figure is 252 and x is equal to 2y, the perimeter of the figure is. Well, x is equal to 2y, so we can put everything in terms of y. Y, 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 and so on. And then that will make it just that much more easier for us to figure this out. Okay, so the perimeter, let's count all the y's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 y. Okay, and the area is 252. So I think the area I can figure out by just chopping this into segments like this, like that. Now we can figure out the value of at least one of these letters, x or y. 252, it looks like from this guy, that is 2y times y, length times width. And then same thing for this part, 2y times y. And then this part, 2y times y. And then this part is just going to be y times y. So there we go. So that's 2y squared plus 2y squared plus 2y squared plus y squared. So that's 7y squared is 252. So 252 divided by 7, and that is 36. So that means y is equal to 6. And therefore, the perimeter is going to be 16 times 6. And 16 times 6 is 96. So, number 16, the answer is 8. The 5 sides of a regular pentagon are all equal in length. Also, all interior angles of a regular pentagon have the same measure. In the diagram PQRST, it is a regular pentagon, and PUT is an equilateral triangle. The measure of an obtuse angle QUS is. Well, let's join Q, U, and S to figure out that kind of shape. And let's start filling in what we know. Well, PUT is equilateral, so these are all 60s. That's pretty easy. And then the interior angles of a regular pentagon have the same measure according to the question. We already knew that. All the angles combined equal 540. And even if you didn't know that, you can look at a pentagon and see that it's basically 3 triangles. Each triangle, you definitely know, has a sum of 180. So 3 triangles would be 540. And then there's 1, 2, 3, 4, 5 interior angles. So you would take 540 and divide by 5, and that would give me 108. So each interior angle, like this one, is 108. So this is 108 from there to there. Well, if that's 60, then this is going to be 108 minus 60, right? So 108 minus 60 is this angle right here. And that is what, 48? Yeah, 48. So that's 48, that's 48. Now this is an equilateral triangle, so this is the same as that, is the same as that. It's also a regular pentagon, so all the sides are the same. So notice in this triangle, this is isosceles. So that means this angle is the same as that angle. So 2x plus 48 is equal to 180. And therefore 2x is equal to 132, x is equal to 66. So let's put that in there, 66. And the exact same story would hold true on this side. It's pretty much the same thing. So now we look at all the way around. All the way around is 360. And 360 will be equal to all the angles that are there. The 66, the 60, the 66, and the angle that we are interested in, QUS, angle QUS. So when you do this math, QUS is 360 minus 60 minus 66 minus 66, and it's 168. So number 17, the answer is B. How many 7-digit positive integers are made up of 0 and 1 only and are divisible by 6? We have 7 digits and has to be divisible by 6. Well, the only numbers I can put are 0 and 1, so the last digit must be a 0 in order for it to be divisible by 6. If it's a 1, there's no way it'd be divisible by 6. Because if multiples of 6 never have a 1 as the last digit. You can try it. You'll see. It'll never be a 1. So I'm confident that the last digit is 0. Now we have to figure out what to do here. Well, if a number is divisible by 6, 6 is equal to 2 times 3. The number is also divisible by 3. So if a number is divisible by 3, the sum of the digits are divisible by 3. Sum of digits is divisible by 3. That's one of the more common divisibility rules. So I've got to place 1s and 0s in a way so that the sum of these digits is divisible by 3. How can I do that? I have a certain number of 0s and a certain number of 1s. All right, let's see what happens here. If I put all 0s, so 6 0s and 0 1s, that's going to work. But it won't, because then we'll have this, which is basically 0, and that's not a positive integer. So that one's gone. How about if I put 3 ones and 3 zeros. That will work, because then it'll be 1 plus 1 plus 1, which is divisible by 3. And the only other way is if you have 6 ones and 0 zeros. The 6 ones basically are like this. So there's only one way of doing that. So there's only one possible way of making that number. But this has a few possibilities. A number where there's 3 ones. So somewhere in here we got to put 3 ones, and somewhere we've got to put 3 zeros. The lead-off number, though, must be a 1. And the reason is because if the lead-off number was a 0, it would no longer be a 7-digit number. It would be a 6-digit number. So we got to put a 1 there. So that means that these guys, I have to put 2 ones and 3 zeros. Okay, so at this point, instead of writing them all out, I'm going to use choose notation. So from the 5 slots, I have to choose 2 to place the ones. And then from the remaining 3, I choose those 3 to place the zeros. So 5 choose 2 is what? 5 times 4, 20 divided by 2, 10. And 3 choose 3 is just 1. So there you go, 10. So 10 is what goes here. So add them up. 10 plus 1 is 11. There's 11 ways of making this 7-digit positive integer with the conditions of the question. Number 18, the answer is B. The function f has the properties that f at 1 is 6 and f at 2x plus 1 is 3 times f at x for every integer x. What is the value of f at 63? F at 63. Well, let's go backwards here. 63 is equal to 2x plus 1. So that means 2x is equal to 62, and therefore x is equal to 31. So that means f at 63 is equal to 3 times f at 31, entirely based on that equation. Let's keep going. Let's try f at 31. This time 31 is equal to 2x plus 1, so that means 2x is equal to 30. X is equal to 15. So f at 31 is 3 times f at 15. Let's keep going. F at 15. This time 15 is equal to 2x plus 1. 2x is equal to 14. X is equal to 7. So 3 times f at 7. Keep going. F at 7. 7 is equal to 2x plus 1. So 2x is 6. X is 3. So that is 3 times f at 3. I think we're getting close to the only thing they gave us. F at 3, well, this time I'll do it up here. 3 is equal to 2x plus 1. So 2x is 2, x is 1. So that is equal to 3 times f at 1. All right, we're ready to calculate the numbers now. Well, f at 1 is the only one they gave us. That was 6. So this is 3 times 6, which is 18. So f at 3 is 18. So f at 3 is 18, so put that in there. That makes this 54. F at 7 is 54. F at 7 is 54, so put that in there. And that is, what's 3 times 54? 3 times 54 is 162. So that's f at 15. Let's go here. 162 this time times 3, and that is 486, and that's f at 31. And then finally, we get to this guy, f at 31, 486, and that is 1458, and that's f at 63. So, interesting question. Number 19, the answer is D. The vertices of an equilateral triangle lie on a circle with radius 2. The area of the triangle is, let's draw our circle, and let's attempt to draw an equilateral triangle. All right, I think that's relatively decent. So we've got an equilateral triangle inside a circle. Now what I'm going to do is I'm going to draw some lines that are perpendicular. There's that one, and this one approximately perpendicular. And this one that also is perpendicular to the other side. Okay, now what happens is something very interesting, is that obviously you can see the point there. That is the centroid of the triangle, and it's also the center of the circle. So what that does is it gives us a lot of help. The radius, they're saying, is 2. So the radius is from there to there, since that dot represents the circle's center. So that's 2. But it's also the centroid, and the centroid has a rule that the distance from here to here is twice the distance from there to there. 2-to-1 ratio. So if that's 2, then this must be 1. And this is a right angle. So now we can easily use the 30, 60, 90 rule to calculate that side. So this is obviously 30 degrees from here to here. This is 60 degrees since it's equilateral. So that means 2 plus 1, which is 3, this whole side, over this side, which I can just call whatever x, is the same as the ratio of the sides. And the ratio of the sides of a 30, 60, 90 triangle are always 1 root 3 for that side and 2 for that side. So that would be root 3 over 1. That would be the ratio. Okay, so that means 3 over root 3 is x. And just rationalize this, so it'd be 3 root 3 over 3, which is just root 3. Yeah. Okay, now we're ready to figure out the area of that triangle. Area of that equilateral triangle, 1/2 base times height. The base is from here to here, which is 2x. So that's going to be 2 root 3. The height is from there to there, which is 3. So there we go. So that looks like 3 root 3. And therefore, number 20, the answer is A.